Welcome to How It's Made, HashMaps edition. I want to put a disclaimer that this is a super primitive implementation based more on the idea of a hash map than the real-world implementation, as getting the hashing to work in a reasonable amount of space is a little bit more work than we need to concern ourselves with at the moment. So let's download the starter code and roll out. Starting with our entry helper object, this is kind of like our node in our linked list, except that it wraps both the key and the value of our map entry, and that's it. We only have getters since we never really modify an entry, we're just going to replace it. You will notice that we're using two generics, k and v, for key and value. Since our types might not be the same, we need to specify both generics. Then, let's look at our dictionary interface. I took a subset of the relevant Java map interface methods, a lot of which should look familiar. We have our size, isEmpty, put, which is map's version of add, a replace, which is a special type of put, and the ability to get and remove based on your key value. And then a few options to check if there's a contains key or contains value. Now, going over to our hash map itself, we see everything is set up for us, and I use an absolutely massive array to store our key value pairs. This is just to support our test cases and get the idea across, but you would never actually do this in the real world. It's horribly inefficient. And we're also going to be making use of our hashing util from the hashing video I released a little bit earlier. I've already handled the methods and logic related to size and isEmpty, so that we can focus on the more map-specific stuff. For contains key, we can actually use our hashing util to do the work for us. We're going to set our hashed version of our key as a long hash key equals hashingutil.hash key.toString, since the hash takes in a string. Next, let's do if entries at index hash key converted to an int equals null. Again, we have to do this conversion since arrays use ints, not longs as indices. Now, in our if block, we're going to return false because if our entry is null, that means we haven't put anything in there at that index. Otherwise, return true because the key maps to something. Contains value is a little bit more annoying. We need to loop through the entire array, check each entry for the value, and only return true if we manage to find it. So we do for entry k, v, entry, colon, this dot entries, then in the loop, if entry does not equal null, and entry.getValue.equals key, return true, because we found it, and then outside of our for loop, return false. Put is a little bit easier. We're going to do that hashing logic from before, long hash key equals hashingutil.hash key to string, and then simply set the entry using that key. Entries of hash key converted to int equals new entry key value. Replace, it's 99% the same thing, but with one additional check. We do if this dot contains key of our key, then the logic from put, but without incrementing the size. And that's it. Get, again, super easy. Do that same logic from replace, but return the entry instead of replacing it. And return null if it isn't in our map. We could throw an exception, but we want to keep it simple for now. Lastly is remove, which again, we want to do that same check, set that entry to null, followed by decrementing our size. And that's it. Let's go over to our test code where I've provided a fairly intricate test framework for all of our methods. We run it, and we see the results correspond to what we expect to happen based on the order of our calls. I'll leave it to you to verify it step by step. I hope this video has given you some good insight into what hash maps are and what they try to do. Next up on our docket is trees, another one of our most important data structures topics. It's also complemented with tons of implementations like lists were, so we'll cover a good number of them before moving on to our last data structure, graphs. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.